Okay, everyone. In this video, I'm going to cover question 6, which I believe comes from the self-study questions sheet number 4. Either way, it is the sheet that covers binomial distributions and discrete probability distributions. Okay, so in this question, we're actually going to be looking. In this question, we're dealing with a binomial distribution. So what I'm going to do is just give a little bit of an overview of what a binomial distribution is, and then most importantly, how we can use the information within the question to be able to identify that it is indeed a binomial distribution. Okay, so let's read through the question. So there's a recent study at QUT found that 70% of all MBA students intend to start their own business at some time in the future. A random sample of 20 MBA students is taken. What is the probability that yada yada yada? So what's happening in this situation is we have a certain thing that we're interested in. And the key thing that we're interested in is whether or not an MBA student starts their own business. And so in that case, if we think about that as an independent event, if we ever think about the event, or trials as they're sometimes referred to, we have it is, say, student, to be MBA student starting their own business. Now, whilst that is the event that we are interested in, or should I say the main thing that all the questions come down to, we're actually interested in the number of times this actually occurs. So if you have a look at the questions A, B, and C, we've got at least 12 intended on-site in their business. So if I take a selection of 20, and I know that the probability that each of them is 70% that they will start their own business, what's the probability that of those 20, 12 start their own business, or in this case, in part B, between 12 and 18, or exactly 14? So the event here is that the MBA is starting their own business, but the variable that we're looking at, and I'm just going to use X because that's the common notation employed in this class, the key thing that our questions are centered around is the number of MBA students that start their own business. So we're actually interested, what we want to do is we want to answer questions that are surrounding X, where X is the number of events that are just, they're like a true-false situation. They either start their own business or they don't start their own business. So when we have these sort of cases where we have an event where it's just a binary yes, no, true, false sort of an outcome, and we want to know, okay, if we repeat this experiment or repeat that event X number of times, in this case that would be N number of times, what's the probability that out of doing it, say 20 or 30 times, that I have 10 that do this or 12 that do that? So that's when we're dealing with a binomial situation. Okay, so when it comes to, so in this case, X is a binomial variable. Now there are two key parameters that we need to identify when we're dealing with any questions that involve modeling a binomial distribution, and that is N and P. So N refers to the total number of events that we're looking at investigating. So in this case, we've got 20 MBA students. So that's the total number of students that we're looking at. So we've got N is equal to 20. Now P refers to the probability. I generally write it out as the probability of success for a single event. So as I said, remember, it's all about however many number of these students start their own, MBA students start their own business. So we need to know the probability. In this case, P refers to the probability that an MBA student starts, sorry about this, their own business. And that information is given to us in the question. That is 70%, or 0.7 as a decimal figure. Okay, so now we've identified it's a binomial variable. We define that as X, which is the number of MBA students to start a business. We've got the two parameters that we need in order to be able to work with a binomial distribution. We can now jump into answering the questions. So what I'm going to do is I'm actually going to start with C, because C is the easiest of the what, and then I'll work backwards. So it says here exactly 14 intent on site on their own business. So how that is reflected is that we've got the probability that X is equal to 14. Remember that X is the number of MBA students to start their own business. So this translates to the number of MBA students to start their own business is equal to 14. So we're answering this question exactly. Now, in order to do this, we could go to the formula that's associated with the binomial distribution and use that. However, you don't really get any extra points for doing that in any way, shape, or form. The binomial tables are provided. And so we can get all of the information we need to answer all of the questions using the binomial table. And I don't want to say this is an absolute definitive rule, but I'm 99.99% sure that in an exam situation, if you can't answer it with the binomial tables that are provided to you, then you've made a mistake in how you've interpreted the question. Okay, so you'll see that when it comes to the binomial tables, there are multiple tables. And there are two key things that are associated with each table. We've got this n value and this pi value. Well, this n value correlates exactly with the n value that we were just using before, and the pi value is the same as p from what we were doing before. So remember, in our case, for this question, or for all the questions A, B, and C, we've got n is equal to 20 and p is equal to 0.7. So jumping into the binomial tables, we find the table which correlates. So scrolling down, so we're working with this column, which is n is equal to 20, and the pi value that we're working with is 0.7. So these are the values that we're going to be working with. So that's how you identify the table, that's how you identify the column. Fairly easy stuff, obviously. So we're looking at the situation of when we've got the probability that x, remember, is equal to 14. So this is where we just went through how to identify what table, what column. This next part is how we identify what row. So we're looking at the situation when x is equal to 14. So if I scroll across, that value is 0.192. And that is the answer to the question. So that's equal to 0.192. And that is it. So if you were doing this in, take-home assignment or any sort of assessment, remember that you would go, from binomial tables. Just so that they know that you definitely went to the tables in order to get your answer. Okay, so let's have a look at what part B says. It says between 12 and 18 inclusive, and inclusive just means that includes the value of 12 and 18, intend to start their own business. So let's have a think about what that means. If it's between 18 and 20, what are the different values that it can take? So that means it can either be 12, 13, 14, 15, 16, 17, or 18. These are the different values in which x can take. So we want to find out the probability, because it's between 12 and 18, that x is equal to 12, 13, 14, 15, 16, 17, or 18. So if we were to write that out, probability x is equal to 12, or x is equal to 13, or x is equal to 14, or, x is equal to 15, or x is equal to 16, nearly done, or x is equal to 18, or x is equal to 19, or x is equal to 20. So that is the long way of writing out what we need to, or what we're trying to find in this question. And so what you'll often find is probabilities like this will be written in a more compact form mathematically. So they'll be written with inequalities. So what I'm going to do is I'll type it out and then I'll explain it to you in case anyone doesn't understand. So how this, I didn't mean to go all the way up to 20 here. This is only meant to go up to 18, sorry. So we've got here, this just means that x is between 12 and 18 and all the values in between. So that's just what that inequality means. So if you were to write it out as this or to write it out as this, you'll get the exact same marks. It's probably best that you write it out this way because I'm not sure if they would in terms of the marking criteria, have that you need to have that one line. But I think it would be pretty unusual if they didn't give you full marks if you were to write it out this way. Anyway, so this is obviously a different setup to what we had before. We're looking at a situation in which we're considering multiple different values for x. Now, the nice thing about if we have a look at these different situations is that they're independent of each other. So we can't, and what I mean by that is if we have a look here, x is equal to 12 or x is equal to 13, we cannot have a situation in which it's equal to both 12 and 13. That just can never occur. And as such, when we're looking at these OR situations, we can use the rules. It sort of came into play, and if you go through the material that's covered in the lecture that covers like the initial introduction of probability theory, you'll find that whenever you've got an OR situation in which the events are independent, it just becomes a sum of the events. So what I mean by that is that becomes probability x is equal to 12 plus the probability x is equal to 13 plus the probability, probability x is equal to 14 plus the probability x is equal to 15 plus the probability x is equal to 16 plus the probability x is equal to 17. And then lastly, plus the probability x is equal to 18. Okay, so now we know how to get these individual values from the table. So we just go to the table here, and what we're going to be doing here is we're going to be starting at 12, and then we're going to be adding up all the values down to 18, if I've lined that up correctly. So what I'm going to do is just take a copy of this, and let's just dump these values down here. So that becomes equal to 0.114 plus 0.164 plus 0.192 plus 0.130 plus 0.072 plus 0.028. So you would plug those values into the calculator and you would get your solution. Okay, so let me just quickly pause the video for a moment. I think we might be going a bit too far. Okay, thanks for that. Yeah, no, so I'm not going to actually answer A. I'm just going to set it up for you because it's relatively easy. We've got at least 12 intend on starting their own business. So we're dealing with a situation of x being greater than or equal to 12. So again, just break it up based upon the different values it can take if it's greater than or equal to 12. So this just means it's going to start at 12 and then it's going to go all the way up to the maximum value, which is 20. So 12, 13, 14, 15, 16. You then get those values, add them up, and you've got your solution. So anyway, I hope that video was useful for you. If you've got any questions, you can either post the questions here, probably better to post them on the Facebook page. Subscribe, like the video if you enjoy it. As I said, any feedback whatsoever, let me know. That'd be great. Anyway, hope that was useful, and I'll talk to you later. Okay, bye.